In the spring of 2000, Dr. Leonard Muller took part in an expedition through Egypt and the Sinai Peninsula.
A research team lowered an underwater drone into the Red Sea at a location that has been debated for 3,000 years. The water was clear at first. The footage was routine. Then the drone went deeper, and what the sonar picked up on the seafloor stopped the team from speaking. The scientists watching the live feed did not have an explanation ready. They still do not have one now. The location. The Gulf of Aqaba sits at the northeastern arm of the Red Sea, bordered by Egypt on the west and Saudi Arabia on the east. It is a narrow, deep body of water, in some places dropping more than 1,800 meters straight down. The water is warm at the surface and cold and dark below. The seafloor is not flat. It is broken and complex, shaped by the same geological forces that pulled the Arabian Peninsula away from Africa over millions of years, creating a rift that the sea filled from below. This is the location that a growing body of researchers, working across archaeology, marine geology, and biblical history, has identified as the most historically defensible candidate for the crossing described in the Book of Exodus. The identification is not new. It has been argued in academic and independent research circles for decades. What is new is the technology that now allows researchers to actually go down and look at what the seafloor contains. The specific site within the Gulf of Aqaba that drew this expedition is a feature called the Nueba Crossing, a natural underwater land bridge that extends from the Egyptian Sinai coast across the floor of the Gulf toward the Saudi Arabian shore. The bridge sits at a depth that would have been accessible as dry land during periods of lower sea level. It is wide enough, approximately 11 kilometers at its widest point, to accommodate a large number of people moving across it. And the seafloor on either side of it drops away sharply, creating the kind of natural corridor that the Exodus account describes the parted water forming on each side. The drone went in at Nueba. What it found changed the way the team understood what they were looking at. The crossing question. The Exodus account of the parting of the Red Sea is one of the most widely known narratives in the ancient world. It appears in the Hebrew Bible, is referenced in the New Testament, is present in the Quran, and has shaped the theological and cultural imagination of three major world religions. It is also one of the most contested accounts in the historical and archaeological record, not primarily because of the miracle it describes, but because of the basic question of where it happened. The traditional location assigned to the crossing, somewhere in the vicinity of the modern Suez Canal, has been the subject of serious archaeological skepticism for most of the 20th century. The northern route through the Sinai Peninsula, which the traditional identification implies, does not produce archaeological evidence consistent with the scale of movement the Exodus account describes. The seafloor in the Suez region is shallow. The conditions required for the kind of crossing the text describes, walls of water on both sides, a path wide enough for a large population moving quickly, water that returns suddenly and completely, do not match the geography of the northern Sinai coast. The Gulf of Aqaba identification addresses these problems systematically. The water is deep enough, on both sides of the Nueba land bridge, to produce walls of significant height. The width of the bridge provides the corridor. The depth on either side means that water returning over the crossing would have done so rapidly and completely. And the Saudi Arabian shore, on the eastern side of the crossing, places the subsequent journey through the wilderness in territory that is geologically consistent with the Exodus account's descriptions of the landscape. Grok's analysis of the full body of research on this question, including satellite imagery, bathymetric surveys, geological studies, and the historical textual record, produced a single conclusion. The Gulf of Aqaba site is not just the most defensible candidate. It is the only candidate that satisfies all the conditions the account describes simultaneously. The drone was sent to find out what the seafloor at that site actually contains. The drone goes down. The research vessel held position at the Nueba site while the team prepared the ROV, a remotely operated vehicle equipped with high-definition cameras, sonar mapping capability, and lights powerful enough to illuminate the seafloor at significant depth. The fiber optic tether connecting it to the control station on deck would allow real-time transmission of everything the drone saw, recorded in full resolution. The first 30 meters were what the Gulf of Aqaba always is in the upper water column, clear and blue, lit from above by the strong desert sun. Coral growth on the upper slope of the land bridge was visible and healthy. Fish moved through the frame and out of it. The footage at this depth was beautiful in the way that Red Sea footage always is, and the team watching the monitors in the control room was relaxed. The relaxed atmosphere did not last past 80 meters. At that depth, the natural light from the surface is gone. The drone's own lights took over, projecting forward into water that had shifted from blue to a heavy pressing darkness. The coral gave way to bare rock and sediment. The temperature of the water dropped measurably. The seafloor ahead began to flatten out onto the upper surface of the land bridge itself. The sonar was running continuously, building a three-dimensional map of the terrain below and ahead of the drone as it descended. The map it was building was consistent with the bathymetric surveys that had identified the land bridge in the first place, a broad, relatively flat surface extending across the floor of the Gulf, with deep water dropping away sharply on both sides. The team had seen this on charts. Seeing it rendered in real-time sonar while the drone sat above it was a different experience. The team directed the drone to move laterally along the upper surface of the bridge, holding depth, sweeping the sonar and cameras across the sediment below. That is when the sonar return changed. What the sonar found. Sonar works by sending sound pulses into the water and measuring what comes back. Different materials return the signal differently. Soft sediment absorbs and returns a weak signal. Rock returns a stronger one. And objects with irregular geometry return patterns that experienced operators can distinguish from natural seafloor features. The team had experienced operators. The pattern that appeared in the sonar return at a specific location on the upper surface of the land bridge was not consistent with natural seafloor geology. It was not the smooth return of flat sediment or the irregular scatter of exposed rock. It was a series of discrete returns, objects distributed across a section of the bridge surface, returning signals that indicated they were made of material denser than the surrounding sediment. The team held the drone in position and switched the cameras to maximum sensitivity. The sediment on the bridge surface was fine and light-colored, typical of the Gulf of Aqaba at this depth, where centuries of accumulation have laid a consistent layer over the underlying rock. But at the locations where the sonar was producing the anomalous returns, the sediment surface was not uniform. There were shapes beneath it. The shapes were too regular and too consistent in their distribution to be random geological features. The drone was directed to move closer to the seafloor, bringing the cameras within range of detailed imaging. What the cameras resolved, as the drone descended to within a meter of the bridge surface, were objects partially buried in the sediment. They were not rock formations. They were not coral structures. They were objects with geometry that sediment does not naturally produce. Curved surfaces, elongated forms, arrangements that repeated with a regularity that natural processes do not generate. The team in the control room stopped talking. What they were looking at. The enhancement process, running the HD footage through image processing software to clarify what the sediment was partially concealing, took several hours. The team worked through it without breaking for a significant meal. What the enhancement revealed, object by object, across the section of the land bridge the drone had surveyed, was a collection of forms that the marine archaeologist on the team identified without hesitation. Wheels, not complete, not fully preserved, not in the condition of objects recently placed. These were objects that had been on the seafloor for a very long time, encrusted with coral growth, partially buried under centuries of sediment accumulation, degraded in the way that organic and metal materials degrade in salt water over extended periods. But the basic geometry was intact enough that the identification was not ambiguous. Chariot wheels. In the coral and sediment on the floor of the Gulf of Aqaba, on the surface of a natural land bridge that crossed the Gulf from the Egyptian Sinai to the Saudi Arabian coast, at a depth consistent with water that would have covered the bridge when it was last in use as a crossing point. The team's marine archaeologist noted for the record that coral does not grow on soft sediment. It grows on hard substrate. The coral incrustation, visible on several of the objects, confirmed that the objects themselves were providing the hard substrate for the coral, which confirmed in turn that the objects were real, solid, and had been on the seafloor long enough for significant coral communities to establish themselves on their surfaces. The sonar count of anomalous returns across the surveyed section of the bridge gave a number large enough that the team did not immediately accept it. They ran the sonar sweep again. The number was consistent. There were not a few objects on the land bridge. There were many, distributed across a wide area of the surface, in a pattern consistent with a large number of objects being deposited simultaneously rather than accumulating gradually. The Exodus account describes the Egyptian army, chariots, horses, soldiers, entering the corridor of the parted sea in pursuit of the Israelites, and the water returning over them before they could cross. If that account describes a real event at this location, the seafloor of the Nueba land bridge is exactly where the physical evidence of it would be. The drone had found it. What was already known? The drone footage was new. The identification of the Nueba site as the probable location of the Exodus crossing was not. In the 1970s and 1980s, a series of researchers working independently arrived at the Gulf of Aqaba identification through different lines of reasoning. Ron Wyatt, an amateur archaeologist who became one of the most controversial figures in biblical archaeology, claimed to have found chariot wheels and other objects on the Nueba land bridge during underwater exploration in the 1970s. His claims were dismissed by the academic establishment, not primarily because his evidence was examined and rejected in detail, but because his amateur status and explicitly religious motivation made his conclusions easy to set aside without sustained academic engagement. In later decades, satellite imagery provided independent confirmation of the land bridge's existence at the location Wyatt identified. Bathymetric surveys conducted for purposes unrelated to biblical archaeology confirmed the depth profile of the bridge, including the broad crossing surface, the deep water on both sides, and the approach gradients on both the Egyptian and Saudi shores that could allow large groups to descend and ascend without obstruction. A documentary-affiliated research team obtained Saudi permission for limited underwater surveys in the early 2000s. The footage they recovered included images of coral-encrusted objects on the seafloor, including one interpreted as a wheel with visible spokes. That identification was disputed, and the footage was never widely circulated. Saudi authorities later tightened access to the region, which lies within waters they control and treat as sensitive in relation to investigations connected to the Exodus narrative. The drone footage from the current expedition was obtained in international waters at the outer edge of the site. It is the most detailed mapping yet of the land bridge surface, and the sonar reconstruction offers a clearer view of object distribution than earlier surveys achieved. It does not stand alone, but continues a longer sequence of attempts to document the same feature using different technologies and institutions. Across these efforts, a pattern has gradually emerged. Independent observations have repeatedly pointed to the same geological structure, the same unusual crossing geometry, and the same cluster of underwater anomalies. Each dataset has been limited by access, technology, or interpretation, but together they form a growing body of evidence that is difficult to dismiss as random or isolated. The previous research did not resolve the question, and the drone did not either. It extended continuity of observation, linking earlier claims and partial surveys into a more coherent spatial record than has ever been publicly available. The geological picture. Understanding what the drone found requires understanding what the land bridge is and how it was formed. The Gulf of Aqaba is a rift valley filled with seawater. The rift that created it is part of the same geological system that produced the East African Rift Valley, where tectonic plates are slowly pulling apart, thinning the crust and allowing the land to sink. The Gulf of Aqaba formed when the Arabian Plate moved relative to the African Plate, opening a narrow, deep channel that the Red Sea filled. Within this channel, the natural seafloor topography includes underwater ridges and plateaus that rise above the surrounding deep water. The Nueba land bridge is one of these features. It rises from the deep floor of the Gulf to a surface that, at its shallowest points, sits roughly 800 meters below the current sea surface. Sea levels during the periods relevant to the Exodus dating have fluctuated, and there are intervals in the geological record when the bridge surface would have been significantly closer to the water surface than it is today. The conditions under which the Nueba Bridge could have been exposed as dry land or near-surface ground, capable of supporting foot traffic and wheeled vehicles, are not confined to miraculous intervention. The geological record includes periods of lower sea level during which crossing at this point would have been physically possible without supernatural assistance. What the Exodus account adds to this baseline is a specific mechanism, a wind-driven separation of the water that exposed the crossing and then ended suddenly, and a specific timing, not a gradual sea level change over centuries, but an event within a single night. The sonar map the drone built showed the surface of the land bridge in more detail than any previous survey. The bridge is not uniform. It has areas of exposed rock, areas of heavy sediment accumulation, and areas where anomalous sonar returns cluster, suggesting objects beneath the sediment, producing a different signal. The distribution of those returns follows a natural corridor across the bridge, concentrated along the central path rather than dispersed randomly across the slopes and edges. Objects deposited by a gradual process would tend toward random dispersal, influenced primarily by currents and sediment movement over time. Objects deposited by a single high-energy event involving coordinated movement across the structure would tend to align along a directional path of travel. The distribution mapped by the sonar is consistent with a directional pattern rather than a purely random one, though consistency alone does not determine cause. It defines the structure of the question more precisely than earlier surveys were able to do, and it narrows the range of explanations that future fieldwork will need to test directly through sampling and excavation. The researchers' response. The team on the research vessel spent the first hours after the drone's return in a way that the lead scientist later described as professionally disorienting. They had gone into the mission expecting to produce a detailed map of the land bridge and to document the geological features of the site. What they had instead was footage of objects on the seafloor that their geological training had not prepared them to categorize, and their professional framework had not given them vocabulary to discuss publicly without significant caution. The marine archaeologist on the team was the most direct in the immediate aftermath. The objects were consistent with ancient wheeled vehicles. The coral incrustation was consistent with extended submersion, centuries at minimum and more likely millennia. The distribution pattern was consistent with a depositional event rather than a gradual accumulation. None of these assessments committed the team to a specific historical identification, and the marine archaeologist was careful to frame each one in terms of what the evidence was consistent with rather than what it proved. The lead geologist on the team spent the first night after the dive going back through the sonar data repeatedly. The number of anomalous returns in the surveyed area was not decreasing with additional analysis. If anything, the second and third passes through the data were resolving additional returns that the first pass had not flagged. The distribution across the bridge surface, when plotted on the map the sonar had built, extended further in both directions along the crossing axis than the initial processing had suggested. The scientist who had the most difficult time with the footage was the one who had come on the expedition as a skeptic, a geologist with no personal religious investment in the Exodus account, whose role on the team was specifically to provide a perspective grounded in the assumption that the site would produce interesting geological data and nothing more. He was the last person to leave the control room that night. He was asked the following morning what he thought. He said he needed more time. What all of them agreed on was that the footage required follow-up. The drone survey had covered a section of the land bridge, not the whole of it. The sonar map was detailed for the area covered and silent, about the areas that had not been reached. The objects identified were documented but not retrieved, since the team had no permit for physical recovery, and the location of the site, in relation to Saudi territorial waters, made any recovery attempt a diplomatic and legal complication beyond the scope of the expedition. What the footage established was the existence of something on the seafloor of the Nueba land bridge. What that something was, in terms of its origin, age, and historical significance, remained unresolved. The data expanded the scope of the question rather than closing it, and it did so in a way that required further investigation before any confident interpretation could be responsibly made. The historical record and the site. The Exodus account places the crossing of the sea within a specific sequence of events that the broader historical record allows researchers to test against external evidence. The dating of the Exodus, always contested and never finally settled, places the event somewhere in the range of the 13th to 15th century BCE, depending on which historical framework the researcher uses and which Egyptian chronology they accept. Egyptian records from this period are extensive. They are also notably silent on the subject of a large-scale Israelite departure. This silence has been used repeatedly as evidence against the historicity of the Exodus. Grock's analysis of this argument produced a straightforward counter-observation. Egyptian records are systematically silent on Egyptian military disasters. The conventions of Egyptian royal documentation did not include recording defeats, humiliations, or catastrophic losses. A pharaoh whose army was swallowed by the Red Sea would not have commissioned a monument to record it. The absence of the event in Egyptian records is exactly what the Egyptian recording conventions predict. What Egyptian records do preserve from the relevant period is evidence of significant Semitic presence in the Nile Delta, the region the Exodus account calls Goshen. They preserve evidence of forced labor programs involving non-Egyptian populations. They preserve evidence of significant social disruption during specific reigns. None of this proves the Exodus. All of it is consistent with it. The Saudi Arabian government's treatment of the Nueba site adds a layer to the historical picture that researchers have noted for decades. The site sits in Saudi waters. Access to it for archaeological purposes requires Saudi permission. Saudi permission for investigations that might produce findings consistent with the Exodus narrative. Findings that would place a significant biblical event within Saudi territorial boundaries and potentially attract the kind of religious attention that the Saudi government has historically been reluctant to invite, has been consistently withheld. The site is not restricted because it contains nothing. It is restricted in the specific way that sites are restricted when those doing the restricting know or suspect what they contain. The drone footage from international waters at the outer edge of the site does not require Saudi permission. It cannot be restricted, and it is now in the record. Taken together, the available material does not resolve the historical question, but it does alter the evidentiary landscape in a measurable way. What was previously discussed in purely textual terms now has a physical correlate in a specific maritime location. Further investigation will depend on access, sampling, and independent verification. Until then, interpretation remains provisional, but no longer abstract. The dataset therefore continues to invite review rather than conclusion at this stage of analysis ongoing present. What the seafloor cannot tell us, the drone mapped what it could reach. The sonar built a three-dimensional picture of the land bridge surface within the area the tether allowed the ROV to cover. The cameras documented what the lights could illuminate, and the team returned with footage that confirmed the presence of objects on the seafloor that the geological framework of the site does not easily explain. What the footage cannot establish is the moment of deposition, dating objects on the seafloor is not a task that camera footage can accomplish. Physical samples are required for the kind of analysis that produces dates. Physical samples were not retrieved. The coral encrustation visible on the objects gives a minimum time estimate. Coral communities of the size and type visible in the footage require significant time to establish, but coral growth rates vary with water conditions, and a precise date range from coral coverage alone is not available. What the footage also cannot establish is the specific identity of the people or army to which the objects belonged. Wheels on the seafloor of the Gulf of Aqaba are consistent with the Exodus account. They are also consistent with other historical events in a region that has seen naval activity, trade, and military movement across thousands of years. The Exodus identification is the one that matches all the other features of the site simultaneously: the land bridge, the depth profile, the coastal geography on both sides, the direction of travel implied by the distribution pattern. But consistency with an account is not the same as proof of that account. The team's final report from the expedition was careful about this distinction. They documented what they found. They noted its consistency with the known features of the site and the known details of the historical account. They identified the specific gaps in the evidence that further investigation would need to fill, and they recommended a follow-up expedition with physical recovery permits, extended sonar coverage of the full bridge surface, and the kind of material analysis that would allow the objects to be dated and identified with significantly more precision. That follow-up expedition is in planning. The permits are being sought. The footage from the drone mission is what is available now, and it is more than anyone has publicly produced from this site before. Independent review of the dataset will likely focus on sediment context, object morphology, and spatial distribution patterns across the bridge surface. Researchers will also compare the sonar reconstruction with known Rift Valley landform processes in similar marine environments. It will take time and additional fieldwork before any strong conclusion can be responsibly supported. At present, interpretation remains provisional and under review ongoing. The deeper question. The geological picture of the Nueba site, examined without reference to the Exodus account, is already remarkable. A natural land bridge crossing a deep water rift valley at a location between the Egyptian Sinai and the Saudi Arabian mainland, with a depth profile that would have placed the bridge surface at or near sea level during specific historical periods, and with deep water dropping away sharply on both sides. The probability that this specific geological feature exists at this location has been calculated differently by different researchers. What all of the calculations agree on is that the feature is unusual. Natural land bridges of this character in this location, crossing a rift valley of this depth and geometry, are not common in the geological record. This one exists and is measurable today. The objects the drone found on its surface either arrived there by a process the current geological and historical record can explain, or they arrived there by a process that the record preserves only in one specific ancient account. The sonar data does not make that choice for the people looking at it, but it makes the choice more urgent. The team leader, in the final interview recorded aboard the research vessel before the expedition returned to port, said something that captured the position of everyone who had been in the control room during the dive. "The footage does not resolve the question," she said. "What it does is make it impossible to keep treating the question as closed. The seafloor of the Gulf of Aqaba has been there for the full span of human history. What sits on the surface of the Nueba land bridge has likely been sitting there for a comparable span of time. The drone reached it, and the footage now exists in recorded form. The significance of such footage is not that it settles a historical or theological argument, but that it adds a concrete data set to a place previously discussed mostly in abstract terms. Researchers can now examine sediment distribution, object placement, and structural alignment with greater precision than before. Whether these observations ultimately align with known geological processes or point toward unusual historical circumstances remains open to interpretation. What is clear is that the site can no longer be described only through maps and models. It now has direct visual and acoustic records that can be revisited and compared again over time. The drone and sonar revealed seafloor objects at the Nueba land bridge, coral-encrusted and sediment-buried, arranged unnaturally. Scientists say not proof of exodus, but previously undocumented predicted evidence in detail. The seafloor does not move, the footage does not disappear. Subscribe, there is more in the record, and the next expedition goes deeper.